All right, guys. So this video is going to be covering notes 8.4. This will be going over trigonometry. This will be day one. So to start off, we want to talk about something known as your angle of perspective. So in a right triangle, the angle of perspective is called theta. Theta is represented by that symbol that looks like a zero and has a slash between it. So this is theta. So this determines what sides will be labeled opposite and adjacent. So our angle of perspective is going to be theta, and this is how this is going to work. So you'll notice that in this right triangle, we have our theta located right here. This means that this angle right here represents our angle of perspective. So the way that we label these right triangles is going to be the following way. So we're going to label it as hypotenuse, opposite, and adjacent. Your hypotenuse side is going to be the side that is always across the right angle. So for example here, if we take a look here, the side across the right angle, across the 90 degrees, this is your hypotenuse. So you're going to label it as hypotenuse. And next, we can take a look at the side labeled as opposite. The opposite side is across the theta. So if we look at theta, well, across theta would be the side that we label as opposite. And then lastly, the adjacent side is going to be the side that connects the hypotenuse and opposite sides. In other words, the adjacent side is just going to be the side next to theta, right? So if I see theta here, our angle of perspective, the side next to it is known as the adjacent side. Right. And so that's how we go through our process on labeling our right triangle based off of our angle of perspective. Right. So let's practice it here with the next triangle here off to the right. So in the second triangle off to the right here, you're going to notice that theta is located right here at the top at angle A. So this represents our angle of perspective. And we're going to start by labeling the hypotenuse. Remember, the hypotenuse is the side located across the 90-degree angle. So across the 90, this is your hypotenuse. And then if we take a look here at the opposite side, remember the opposite side is across theta, right? So if I look at theta, the side that is across from it would be this bottom side right here. This would represent the opposite side to theta. And then lastly, that leaves us with the adjacent side. The adjacent side would be the last remaining side that is next to theta or attached to theta. Okay. And so we're pretty much going to be following this same type of labeling through every single problem that we do in today's notes, right? So we're going to be comfortable with the idea of labeling our sides hypotenuse, opposite, and adjacent, right? And we'll get more practice with this as the problems arise here throughout the notes. So the whole purpose of us looking at trigonometry is for us to be able to come up with a relationship to represent the side lengths. So trigonometry is basically defined as the ratios that relate the sides and angles of right triangles. So this stuff here is actually extremely important, right? So we have three different trigonometric ratios. The first one that we look at here is known as sine. So sine of theta is going to be set up as opposite over hypotenuse. Cosine of theta is going to be set up as adjacent over hypotenuse. And then lastly, tangent of theta is going to be set up as opposite over adjacent. So these three trig ratios, trig is short for trigonometry, these three trigonometric ratios allow us to set up ratios to find missing sides and missing angles of right triangles. So the acronym that we have to remember this is known as SOHCAHTOA, right? This here tells us if we write it down underneath, sine is going to be opposite over hypotenuse, O over H for short. Cosine is adjacent over hypotenuse, so A over H for short. And then T, which is pronounced tangent, tangent is opposite over adjacent, right? So these just represent ratios that we can set up with the given sides that we have in a triangle. So what we're going to do is we're going to practice identifying these ratios within a right triangle. So if we take a look here at number one, number one is asking us to write the ratio for sine of theta. Well, if we look at sine of theta, well, let's take a look at theta. Theta represents your angle of perspective, right? And keep in mind that your angle of perspective is going to be your viewpoint of the right triangle. And so if we're going to go ahead and begin labeling our right triangle, I always recommend labeling the hypotenuse first. The hypotenuse is the side across the 90-degree angle. So this one right here, the 30 represents your hypotenuse. The side that is across theta is known as your opposite side. And the side that is attached to theta, the third remaining side, is your adjacent. So if we take a look at setting up these ratios, the first one they ask us for is sine of theta, right? Well, if we take a look at sine of theta, if I look at sine, sine is O over H, or opposite over hypotenuse, right? Like we see up here. So if we take a look at sine, if I want to write that ratio, the first number that we put on the top of our fraction is the opposite side. So if I look at our picture, the opposite side is 24. So we're looking at 24 over, on the bottom, our ratio of sine has the hypotenuse. Well, the hypotenuse here is 30. So the ratio that we're looking at here for sine of theta is 24 over 30. Next, we could take a look at the ratio for cosine of theta. Well, cosine of theta is going to be the ratio of adjacent over hypotenuse. Well, our adjacent is going to go on top. The adjacent for theta is 18 over the hypotenuse, which the hypotenuse here is 30. And then lastly, we could take a look at tangent of theta. Tangent of theta, that ratio for tangent is opposite over adjacent. Well, if we take a look at our side lengths here, opposite over adjacent would be opposite is 24 over the adjacent, which is 18. So we get 24 over 18. And so I left this step here for the very end. When you're setting up these trig ratios, you're going to use SOHCAHTOA to help you set the numbers up in the correct place, but you also want to make sure that you're simplifying these fractions whenever possible. 24 over 30 can be simplified if we divide the top and the bottom by 8. So if we divide by 8, what you'll see here is that we get 3. Well, let's not do 8. I'm sorry. Let's divide by, I can divide the top by 8, but not the bottom. Let's divide by 6 here. So if we simplify this fraction by dividing by 6, on the top, 24 divided by 6 gives us 4, and on the bottom, 30 divided by 6 is 5. So the ratio for sine of theta simplifies to 4 over 5. Let's do the same thing with simplifying the fractions down below. If I want to simplify this fraction, I'm looking for a number I can divide the top and bottom by. Again, our number is going to be 6. So if we divide the top and bottom by 6, we get 3 over 5. And then at the very bottom here, when we're looking at tangent of theta, we can again simplify this fraction by dividing top and bottom by 6. Doing so, we get 4 over 3. Okay, so those are our ratios for this first problem. Okay, again, we're looking at SOHCAHTOA using that acronym there to help us set up our numbers in the correct place. Okay, let's look at another one here. Let's practice with the next one. It's not always going to be this 0 with a slash through it. It's not always going to be theta. Sometimes they'll actually use the letter for that angle. So for example, if we look at sine of z, that means that the item in the parentheses represents your angle of perspective, right? So z is our angle of perspective. I'm going to label it like this. And as I start to label the sides of the right triangle, you always start with the hypotenuse first. Hypotenuse is across the 90, so this is our hypotenuse. I'm going to put HYP for short. The side across the angle of perspective is your opposite, so this is OPP. And then the third remaining side represents your adjacent side. So if we're going to write the ratio for sine of z, right? So sine is opposite over hypotenuse. Opposite over hypotenuse would be 12 over 35. Sorry, not 12 over 35. Opposite over hypotenuse would be, let's do opposite. 12 is on top. Hypotenuse is on the bottom. Hypotenuse is 37. Next, we could take a look at writing the ratio for cosine of z. Cosine of z is going to be, looking at cosine, we're looking at adjacent over hypotenuse. So cosine, we're going to start with adjacent on top, which is 35. On the bottom, we have the hypotenuse, which the hypotenuse is 37. So cosine of z is 35 over 37. And then lastly, we're looking at tangent of x. Tangent is opposite over adjacent. The only problem here is that what we're looking at here is a different angle of perspective. So we see here in the parentheses, we have x. X represents our new angle of perspective, right? And so we are going to have to relabel our triangle. If we take a look at x being our angle of perspective, then if we start across the 90, the hypotenuse has not changed. But what will change now is the side that is across the angle of perspective. So that my angle of perspective being x, the side across from that is 35. So now this becomes opposite. And then the adjacent side would become the 12. So what we're looking at here is the color green for our angle of perspective of x. Tangent of x is opposite over adjacent. Well, opposite here in green would be 35. Adjacent in green would be 12. So our ratio for tangent of x would be 35 over 12. And so that would represent how we find and identify these trig ratios for a right triangle. Okay, the rule of thumb here is label your sides based off of your angle of perspective, label your hypotenuse, your opposite, and your adjacent. Okay, you'll get more comfortable with these the more that you practice. Okay, let's go ahead and move on with the notes, and we can start to see how is trigonometry helpful for us to find missing sides of a right triangle. So what you'll kind of see here in the next section of the notes here is how to set up our equations here when it comes to solving for missing sides using trigonometry. So here are some steps that you can follow. The very first thing you want to do is mark your angle of perspective. After you mark your angle of perspective, then you're going to label your sides. You're always going to start with the hypotenuse. So always start labeling with the hypotenuse first. Step 3, you're going to select the appropriate trig ratio and set up your equation, right? Trig ratio is referring to either sine, cosine, or tangent based off of the given sides you're working with. And then step number 4 is you're going to put the left-hand side of your equation over 1 and cross multiply to solve, okay? Your answers will end up as a decimal, okay? What we'll do here is we're going to round to the nearest hundredths, which means 2 decimal places unless stated otherwise. Now, here comes probably one of the most important parts of the notes whenever we're using trigonometry. What we're looking at is the part highlighted in yellow. When you're using trigonometry, your calculator must be in degree mode. So please keep in mind that not only do we have to be in degree mode when doing trigonometry, but you can only use trigonometry on right triangles. So this only works if you're looking at a right triangle. That's the only time that you can use trigonometry. So let's kind of have the conversation now of what does it mean for a calculator to be in degree mode. So the calculator that I'm going to be using in today's notes is known as Desmos. Okay, so Desmos is a calculator that was used last year in Algebra 1. To make sure that our calculator is in the right mode, if you're using Desmos, click this little wrench icon. When you click on that wrench icon, you'll notice that at the bottom of this pop-up screen, you'll see that there is a little section here that's titled radians and degrees. We want to be in degree mode when we're doing trigonometry, so I'm going to click the degree mode to make sure that our calculator is in the correct setting. So always make sure that you're in degree mode for our class. And so now that we're in the correct mode, I'm going to go back to the notes here and write down what is the purpose of using trigonometry. The purpose is we use trigonometry to find missing sides and angles when we do not have enough information for Pythagorean theorem, or special right triangles. So in other words, we use trigonometry here when we can't find a missing side length by using Pythagorean theorem, a squared plus b squared equals c squared. Or if we see that we cannot find a missing side by using special right triangles. Your special right triangles are your 45, 45, 90, or 30, 60, 90. Okay, so if neither of these two methods work to find a missing side of a right triangle, we can typically rely on trigonometry to help us find missing sides. So let's look at some examples here that actually have us looking for a missing side of a right triangle so that we can see how this works. Okay, now the setup here, I'm going to walk you through these 4 steps throughout every single problem. So in the first example, okay, we're looking at example 3 here. What you'll notice here is that we have a right triangle. This right triangle has an angle of 49 degrees labeled. So we're going to mark this here as our angle of perspective. Now, if this is our angle of perspective, that was step number 1. Step number 1 is mark your angle of perspective, which we have done. Step number 2 is to label your sides. So when we're labeling our sides, remember, we always start with the hypotenuse. The hypotenuse is across the 90, so this is our hypotenuse. And then if we look at the side across the angle of perspective, that is opposite. And then the third remaining side is your adjacent. And so what we're using now after that we've labeled it, that's step two. Step number three is to choose the appropriate trigonometric ratio. So we have SOHCAHTOA to help us make sure that we're using the correct ratio. The way that you're going to decide which trig ratio to use, either sine, cosine, or tangent, is you're going to look at the two sides that you're working with. Well, I'm working with x, which is adjacent, and 9, which is hypotenuse. Which one deals with adjacent and hypotenuse? Well, not this one. It's the middle one, which is cosine. So I see here that I'm working with adjacent and hypotenuse. So what we're going to do is we're going to set up an equation here. So keep in mind that our ratio for cosine is set up the following way. Cosine of theta is equal to adjacent over hypotenuse. So our setup, okay, and this is going to be our equation that we set up here, is going to be cosine of theta. Theta represents the angle of perspective, right? Your angle of perspective that we used in this triangle is 49 degrees. So this is going to be written as cosine of 49 is equal to, well, adjacent over hypotenuse. What is adjacent here? Adjacent is x. So we have x over the hypotenuse, which is 9. And so that is going to be how we set up the equation here. Now, they're not asking us to just set up an equation. They want us to find the value of x. So if we want to find the value of x, this is what brings us to the next step in the problem solving process, which is going to be taking the left side of our equation, this cosine of 49, we're going to put this over 1 so that now we can cross multiply. If we cross multiply, what we're doing here is we're multiplying diagonally. We're doing 1 times x is equal to 9 times cosine of 49. So if we multiply the green diagonal, 1 times x is x, is equal to 9 multiplied by cosine of 49. And so really that's our value for x. What I want y'all to understand here is that this represents your exact answer. So x is equal to 9 times cosine of 49, right? The only thing is if I tell you that, it's not very clear how long that side x is, right? So this is where we're going to use the calculator. We're going to type in 9 times cosine of 49. So I can show you how this works in Desmos. We're looking at 9. So they pull up the keyboard here. We're looking at 9 times. To find cosine, sine, and tangent, you're going to click the functions button. So we had 9 times cosine of 49. And what you'll see here is this is our answer. We have 5.9045312691. Now what we typically do here is we round to the nearest two decimal places. So rounding to the nearest two decimal places, I'm looking at the 90, and then I'm looking at the number afterwards. If that following number is 5 or more, then that means it rounds up to 0.91. If it's less than 5, which here it is, then it stays as 0.90. So our answer here is x is approximately 5.90. And so this is how we solve for missing sides using trigonometry, okay? Using those 4 steps. Now, again, this is going to be something brand new. You're going to feel more comfortable with this with the more practice that we do. So let's look at the next example. So if we look at the next one, okay, we're going to follow the same 4 steps. If we look at number 4, then we have the following right triangle. And what we'll see here for this one is that the angle they gave us was 62 degrees. So this represents your angle of perspective. That's step number 1, mark your angle of perspective. Step number 2 is to label your sides of your right triangle. Always start with the hypotenuse. Across the 90 is your hypotenuse. This is our hypotenuse. Across the angle of perspective is opposite. So this is opposite. And then adjacent would be the side attached to this, which would be x. So there's step number 2. We labeled our triangle. What we're looking at now is which trigonometric ratio are we using? If we're looking at SOHCAHTOA to help us remember our ratios, let's look at the 2 sides that we're working with here. We're working with 9 and we're working with x here. What we have here is opposite and adjacent. So if I look at opposite and adjacent, it's not the first one. It's not the second one. Opposite and adjacent is O and A. We're working with tangent. So we're just going to write that ratio down here. Tangent of theta is equal to opposite over adjacent. So if we're going to set up our equation here, then we're just going to plug in our values. Our equation is going to be tangent of theta, which is your angle of perspective. Theta here is 62 degrees. So we have tangent of 62 is equal to opposite over adjacent. Opposite is 9 over the adjacent, which is x. So there's your setup for your equation. Now, that is your setup for your equation. What we're going to do now is we're going to solve for x. If I want to solve for x, what you're going to do here is you're going to put the left-hand side of your equation over 1, and then you're going to cross multiply. If we cross multiply, we're looking at 1 times 9 is equal to x times tangent of 62. So let's go ahead and multiply this out. We have 1 times 9 is 9. That's equal to, well, here we have x times tangent of 62. So we're going to write it as x times tangent of 62. Well, we're looking to solve for x here. And so this equation looks a little bit weird, but the ultimate goal here is to solve for x. I want the x by itself. So how do I cancel a times tangent of 62? Well, the opposite of times is to divide. So we're going to divide by tangent of 62 on both sides. So what ends up happening now is that the tangents cancel out. And now we're left with x is equal to, well, 9 divided by tangent of 62. Right? This right here represents your exact answer. When you get the x equals part, that is your exact answer. Okay, please label that in your notes because we're going to follow a very specific format when we take our quiz later this week. So our value for x is 9 divided by tangent of 62. So let's go to our calculator and see what value that gives us. So we have 9 divided by tangent of 62. So if I create a new line here, we're doing 9 divided by tangent of 62. Looking at what we have here, we're looking at 4.78538, and the decimal goes on. You're rounding to the nearest two decimal places. So the nearest two decimal places, I'm looking at 0.78. Is this going to stay as 0.78, or is it going to round up to 0.79? To decide that, look at the following number. That following number is 5 or more, so that means it's going to round up. So this will round up to 4.79. So we can see here that 4.79 is the approximate value for x. So you'll notice that whenever we're solving for x and we're rounding, I'm not putting just a regular equal sign. My equal sign has kind of like a squiggly line to it. That means that we're rounding, or this is an approximation, so not exact. Okay. So let's do a few more here and then we'll finish up the notes. So this next one will be a little bit faster now. So as we look at number 5, we're going to start the same way we did for the last two. We're going to start with the angle of perspective. My angle of perspective here is 57 degrees. Now, if that's my angle of perspective, we want to now label our side lengths. Our sides here that we start with is always the hypotenuse, which is across the 90. So this is your hypotenuse. And the side across the angle of perspective is opposite. And then this is adjacent. So if we're looking at our ratios of SOHCAHTOA, sine, cosine, and tangent, what we're going to look at here is selecting the correct ratio. They gave us 16, which is the hypotenuse, and x, which is the opposite. So which one deals with opposite and hypotenuse? We see here that opposite and hypotenuse is O and H, so we're working with this one. So the ratio that we're working at for this problem is sine of theta is equal to opposite over hypotenuse. So that's our ratio, sine opposite over hypotenuse. Now we just plug our values in. So this next part represents our equation, our setup here. The setup for our equation is going to be sine of theta, where theta is your angle of perspective. Angle of perspective is 57. So we have sine of 57 is equal to, now we're looking at opposite over hypotenuse. Opposite over hypotenuse would be x over 16. There's our setup. Now, if I want to solve for x, remember that we put the left-hand side of the equation over 1, and we just cross multiply. If we cross multiply, we're looking at 1 times x is equal to 16 times tangent of 57. Not tangent of 57, I'm sorry, sine of 57. So if I cross multiply here, 1 times x in green gives us x is equal to 16 times sine of 57. You'll notice that as we cross multiply, the x is already by itself, right? So this here represents the exact answer. And now we just have to plug it into the calculator to find the approximate answer, the rounded answer. So x is approximately, let's type this in, 16 times sine of 57. So 16 times sine of 57, we're looking at 16 multiplied by sine of 57. Well, if we plug this in, we're looking at 13.41. The next number is 8, so that 0.41 is going to round up to 0.42. So 13.42 is the approximate value for x. Okay. Two more examples, and then we'll wrap up the notes here. So next, we're looking at this one. Okay. The following one that we're looking at here, now we're looking at an angle of perspective here of 27. Okay. So step number one, label your angle of perspective. Step number two is label your sides. This is your hypotenuse. This is your opposite. This is your adjacent. If we start to highlight what we are given here, we're given with the hypotenuse and we're given the opposite. So let's write down the ratios here that we're working with. We're looking at sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So what we're working with here is, well, we're working with opposite and hypotenuse. So we're working with sine again. So we're working with the ratio sine of theta is equal to opposite over hypotenuse. So our equation, if we're going to set this up, we're going to plug our values in here. Sine of theta, theta is our angle of perspective, 27, is equal to opposite over hypotenuse. Opposite over hypotenuse is 25 over x. Okay, so there's our equation. To solve, what you do now is you put the left-hand side of your equation over 1. We're making this a fraction so that we can cross multiply. If we cross multiply here, we're looking at 1 times 25, which is 25. That's equal to, well, look at the other diagonal, x times sine of 27. So we have x times sine of 27. And as we look at this equation, the x is not by itself, so I don't know what x equals yet. So we want to solve this equation for x. So if I have x times sine of 27, we're going to cancel the times sine of 27 by dividing sine of 27 on both sides. So this cancels, leaving us with now x is equal to 25 divided by sine of 27. And that right there represents your exact answer. So we want to find out the rounded part of our answer. So we want to find out what does x approximately equal. We're going to do 25 divided by sine of 27. So going to our calculator, we have 25 divided by sine of 27. Plugging that in here, we have 55.06. Next number is 7, so that's going to round up from 0.06 to 0.07. So 55.07 is the approximately value of x. Okay. And so in a nutshell, that's pretty much what you're doing here to find the missing sides using trigonometry. Okay. Following those 4 steps, the last type of problem that we're going to look at here in the notes is a word problem. So if we look at example 7, now we're looking at a word problem. Says a ladder leaning against a house makes an angle of 50 degrees with the ground. The foot of the ladder is placed 12 feet horizontally from the house. How long is the ladder? Draw and label the figure. Round your answer to 3 decimal places this time. So if you read that all at once, it's probably going to sound a little confusing. So we're going to draw a picture and we're going to break this up into chunks. So the very first thing that I'm going to read here is the fact that we're working with a ladder. This ladder is leaning against a house. So I'm going to draw a house. Our house here has a ladder leaning against it. So we have a ladder leaning against the house. So let me draw my ladder here. So the ladder is leaning against the house and it makes an angle of 50 degrees with the ground. So the ground is going to be right here. And it's making an angle of 50 degrees with the ground. So that means the ladder is making an angle of 50 degrees and that 50 degrees would be located right here. Now it says the foot of the ladder. Okay, let me use a different color here. So the foot of the ladder is placed 12 feet horizontally from the house. So the foot of the ladder would be right here, and it is 12 feet horizontal from the house. So this means that this bottom side here is 12. They want to know how long is the ladder. So how long is the ladder? The ladder's here in green. They want to know how long it is, so that represents X. I'm trying to use different colors here to kind of let you guys see how it is that we're breaking this problem up into chunks and drawing it and making the connections to how we're labeling this. Okay. But hopefully what we're able to see here is that with this ladder drawn, and the house drawn, we're seeing a shape of a triangle being formed. And we're going to see that we're going to have a 90-degree angle that's created here. Okay, houses stand straight up, and so it's going to be perpendicular, making a 90-degree angle with the ground. So what we're working with here, I'm going to highlight so that we can hopefully see this a little bit easier, is we're working with a right triangle. Okay, here's the right triangle that we're working with. Now I'm going to separate it out so it's a little easier to see compared to like what we saw in the notes. Draw a little bit better here. So we're looking at, gosh, I cannot draw today. Let's try that one more time. Okay, so here is our right triangle. We have a 50-degree angle located here. This bottom side of the triangle is 12, and they want to know the hypotenuse, which is x. So we go through our process. We're looking at our angle of perspective of 50 degrees. Start with the hypotenuse first. This is your hypotenuse. The side across is your opposite, and the third remaining side is your adjacent. So as we look at what we have here, we're working with x, which is the hypotenuse, and we're working with 12, which is the adjacent. So if we're trying to decide which ratio we're going to use, remember that we're looking at SOHCAHTOA to help us decide which ratio to use. So we're working with adjacent and hypotenuse. Adjacent and hypotenuse would be, adjacent is A, hypotenuse is H. We're working with this one right here, which is cosine. So we're working with cosine of theta is equal to adjacent over hypotenuse. So if we want to set up our equation here, our equation is going to be cosine of theta, which theta is 50, is equal to adjacent over hypotenuse. Adjacent is 12, hypotenuse is x, so 12 over x. There's your setup for your equation. If we want to solve this for x, we're going to put this guy over 1, and we're going to cross multiply. If we cross multiply, 1 times 12 is 12. That's equal to, well, x times cosine of 50. Right? Here we see that the x is not by itself, so we need to cancel some stuff out. X times cosine of 50, we're going to cancel the times cosine of 50 by dividing cosine of 50. And now this cancels, and we're left with 12 over cosine of 50 is equal to x. Okay, that right there represents your exact answer. Right, but this question asked us to round, right? If I look here, it said round answer to 3 decimal places. So our answer is looking at the value of x, so 12 divided by cosine of 50. Let's go ahead and see what that gives us, and we're going to round to the nearest 3 decimal places. So 12 divided by cosine of 50 is what we're working with. So 12 divided by cosine of 50. What we get is 18.668, and now we look at the next number. That next number is 5 or more, so it's going to round up. 0.668 rounds up to 0.669. So 18.669 is the approximate value for x. And for these types of word problems, typically they're asking you to find some kind of length of some sort, and length has units. So it said, how long is the ladder? Well, the ladder is approximately 18.669, and the units we were looking at for this problem, the units is, here we see that they were talking about feet. So 18.669 feet would be our answer. Okay, so that's the end of the notes. If you found something confusing or you weren't sure about something, please make sure you reach out to your teacher and get a time scheduled for tutorials to go in and take a look at trigonometry day 1.